let's go over this review for our Chapter 5 exam. If you can understand these problems, you can't help but get a very good grade to start us off for this third marking period. So make sure you understand all the questions on this review. If you have questions, you can need to talk to me. You need to come and see me before we take our exam. So this first part, I already wrote down the answers, but you need to make sure that you understand that a scalene triangle, all sides are different. Okay, that's what makes it a scalene, and it's based on having all three sides being different. The next one, when you have two sides, at least two sides that are congruent, it's called an isosceles triangle. So if I mark up, if I give you a picture of a triangle and I show you that, hey, these two sides are congruent to each other, then we're going to call it an isosceles triangle. Okay, and then if all three sides are the same, then it's equilateral. Okay, so make sure you understand how to classify according to the sides. Okay, then we can also classify according to the angles that we see. So if we see that a triangle has a right angle, it's marked. If it's marked as a 90-degree angle, then we call it a right triangle. That's the definition of a right triangle. And then if we have at least, or it can only be one angle greater than 90, so if we have a angle between 90 and 180, it's going to be an obtuse triangle. Okay, if all three angles are less than 90, then it's an acute angle. Okay, if all the angles are the same, okay, if they're all 60 degrees, they would have to all be 60 degrees, so they add up to 180. We call it equal angular. Okay, so then here, a lot of people forgot this. So I just mainly mentioned this real briefly when we did 5.4, when we were talking about isosceles triangles. We have a corollary that is basically, it follows right from a theorem. It's a theorem that follows easily from a theorem that has already been proven. Okay, so simple definition, we have to kind of remember what a corollary is. Okay, so then this, I promise you this question, that's why I started. You'll see this. So you need to make sure when you see CPCTC, you understand it stands for corresponding parts of a congruent triangle are congruent. So all the corresponding parts. So that's that one extra thing. Once we can establish that the triangles are congruent, then that forces all the other parts then to be congruent. Okay, corresponding parts of congruent triangles are congruent. So the rest of these we will quickly work out. Okay, so I'm hoping that you're willing to check all these answers and make sure. Now, I didn't take any points off on your quiz, but I will take points off if you don't actually have by sides. So by sides, I am looking to see, and in this case, I see two of my sides are the same, so that forces this to be isosceles. Okay, so an isosceles triangle. And then notice all my angles are less than 90, which forces it to be acute according to the angle. So it's an acute isosceles triangle. Here, all three sides are different. So my side measurements are all different. That forces this to be called a scalene. And the good news is I do have a right triangle. I've just marked it 90, but we know it's a right because I see a 90-degree angle. Okay, that first page should have been pretty easy for you. The next part, this is simply just looking at the order of your letters. So I don't have an actual diagram of these two triangles that are congruent to each other. I don't need it. It's all I need to realize is side MA must be the same as side CU. And please put a segment mark. Okay, use the two capital letters and then put a line above to represent a side. Okay, so then TM is this to this. I look over here at this statement. It has to be the same as P to C. PC, it must be congruent to TM. Okay, A is in the middle, U is in the middle. They must match up. Okay, that's how easy it should be to show your congruency statements. Based on this has to be this the original congruency statement, everything has to match up. Okay, this next part should be easy. When I say vertex A, I'm really referring to this angle up here. So angle A, the side opposite, that's the farthest away, is going to be side BC. That's all you're looking at. Adjacent means next to. So if you need to, write next to so that you can associate the word adjacent with next to. You have two choices. The two sides that are next to A is going to be BA or CA. Okay, and again, the order doesn't matter. So if on your paper you have AC, you're fine. If you have AB, you're fine. Okay, order doesn't matter. It refers to a side. Okay, then it's your choice which angle you want. I'm going to use angle B. So I'm just going to say AB and BC. Those two sides share this angle right here, and the included angle is angle B. Two sides and an included angle. So again, they're forcing you to see that if I could establish side, angle, side, and then you have another triangle with that exact same matching, that's how we can prove triangles are congruent. Okay, so basically just testing so that you know some terminology like opposite, adjacent, included, and so on. Okay, the next couple, you need to set up a pretty simple equation. So for number 18, okay, if I didn't tell you that these two sides are the same, this is not enough information. You can't solve for x based on just this diagram. But as soon as you know that AB must be the same as BC, it's really easy to set up a simple equation. Okay, we're already told that this side is 7 inches, 7 meters, whatever the unit is. It's 7, and it has to equal x minus 1. Super easy to solve and know that x is 8. Okay. Then I'm asking, is this an equilateral? Are all the sides 7? As soon as you plug in over here, we'll get a 7. We knew that this has to be a 7, but if you plug in an 8 here, this side is going to only be 5. Not all three sides are the same, so it's not equilateral. Okay, again, you're comparing 7, 7 to a 5. Okay, they all would have to be the same. For number 19, I am telling you the base angles are congruent. And we have like the inverse proof where a theorem that if the base angles are congruent, that forces the opposite sides to be congruent. Okay, that's what we had to recognize. So all I'm going to do is take 6x minus 4, set it equal to 5x. Okay, so once I do that, this one's super easy to solve. You can almost do this one in your head. I'm going to bring over the 5x by subtracting, and I'm going to add a 4. Okay, so x is going to be 4. And then I ask you to find the length of all the sides. These better be the same. So when you plug in a 4 here, you get 20. When you plug in a 4 here, you're going to have 24 minus 4, which is 20. We expected these two to be the same measurements. But then when you plug it in down here, we're going to end up getting 15. Okay, 15 units. So there's all three sides based on x being A4. Okay. Next page. So for number 20, same concept is these markings show that these two sides are the same, which forces the base angles to be the same. So if this base angle is an x, it forces this one to be an x. Okay, and we should all know, add up all three angles and set it equal to 180. Okay, super easy to solve. Once you solve this, you're going to end up, and I'll subtract the 70 right away. You're going to get 110. Take half of 110, and just like that, we know these would each have to be 55 degrees. Okay, again, add them all up. All three angles must add up to 180, so be on the lookout for that. Okay, the next thing for number 21, we are given parallel lines. This is a direction arrow that tells you these two lines, are parallel. Okay, and if we have parallel lines cut by a transversal, I'm hoping you can recognize and look for special angles like alternating interior angles. So as soon as I establish this, I know that y has to be the same as 45, okay? This is marked 45, that forces y, because they are alternating interior angles. And then to find x, all three of these must add up. It's a linear, so straight line, 180 degrees. I take 70 plus my x plus y, which is now 45, set it equal to 180. Add these together, it's going to be 115. Subtract 115, and x would have to be 65. Okay, and that's all I'm asking for. So this would have to be 45. This has to be 65. Again, check all three of these angle measurements add up to 180. Okay. The next one, please don't get this wrong. I give you no other information except I tell you three angles, and we know all three. So show this work on your test. Show me that you add all three angles together and set it equal to 180. Okay, and I promise you a simple equation to solve. Okay, most of you are good at solving. You have the basic algebra 1 skills to be able to then solve correctly. So in this case, you end up with 3x. So I'm going to simplify this. Plus 45 equals 180. I'm going to subtract 45, and it's 135. And when I divide by 3, I get x is 45. And you'll have a calculator to help you understand that. So that's all I'm asking for. I'm just asking you. I'm not asking for the measurements, but if you would plug in, you would see that this would be a right triangle. So if I did ask you to classify this triangle, according to this angle, it is going to end up being 2 times 45, which is 90, which is a right angle. But I'm not asking for that, but just be aware of that. This one, what I'm hoping that you're going to see, this y is an exterior angle. So exterior angle. And you're going to need to go into the test knowing that an exterior angle is equal to the sum of the remote angles, okay? So I know it has to be 55 plus 60, okay? Now, some people could have found this angle right here because I'm giving you 2 out of the 3 angles in this triangle. So if you take 60 plus 55, you're going to end up being able to then subtract that from 180, and you'll know that this is 65, and then you could find its supplement. So bottom line is y must be 115. Okay, it's either 55 plus 60, which is 115, or find this and then take 180 minus 65. And when you take, and I'll show this on a calculator, 180 minus 65, you get 115. So it's your choice how you want to find y. But once I know what y is, once I know that this has to be 115 degrees, and notice it makes sense. This is definitely an obtuse angle. I add my x, I add my y, which I now know is 115 degrees, and I add the 40 that was already there. And I know all three must be 180. When I do that, I end up, and I'll show this on a calculator. If I add 115 and the 40, I get 155. And when I subtract 155 on both sides, 180 minus 155, I get a nice 25. So that forces x to be 25 degrees. Okay, so make sure you know, be on the lookout for external angles. Okay, this one very similar to some other ones that we saw. We have an isosceles, 2 sides marked. That forces the opposite angles to be the same. So if this is angle x, forces this to be angle x. So x plus 30 must equal 180. 2x equals, and I'm going to subtract 30 right away. I get 150. I take half of 150, and I know that x has to be 75 degrees. Okay? So make sure that makes sense. Okay, a couple more to set up. If you look at 25, we have a 90-degree angle. So we're already 90 degrees out of my 180. So you could set up, instead of adding all three, just add these two, the x and the 39, and set equal to 90. Okay, you will get 51 degrees. This has to be 51 so that all three add up to 180, or these two are complementary. They must add up to 90. Okay, number 26, I have three angles. I take the x, I take the 30, and I take the x minus 8, set it equal to 180. Simplify, so we get 2x on this side. It's going to be 22 equals 180. I'm going to subtract 22 on both sides and then divide by 2, and you'll see that x must be 79. Okay, so 79 here. And again, I don't tell you to find the individual measurements, but you could double check, so just so you don't make a mistake. You could double check and make sure that, okay, well, this has to be 30, this is 79, and then this would have to be 71, and they all add up to 180. And it only works if x is 79. Okay, for number 27, we saw this on our quiz. Okay, this is actually a very easy problem to set up, but we have to know this is called an exterior angle. So exterior angle, it's on the outside of the triangle. Well, an exterior angle equals the sum of these angles, okay, the non-adjacent angles. So this is a 2x, this is a 3x plus 20. I'll give you points for just setting up the equation correctly, and then you need to solve correctly. So this is actually pretty easy to solve. I'll simplify this side. It's 5x plus 20. I'm going to bring my x's over to get an x. So if I subtract 4x, I'm left with an x. When I subtracted 20, or excuse me, yeah, so when I subtract this 20, I get a 20. Okay, so this is the work I did. I subtracted the 4x to get an x, subtracted this 20, and I got a 20. 20 must be my answer. Okay, so then the next part, I like this. You have plenty of problems to practice. There's several worksheets that I gave you, additional to our notes and stuff, that you can practice this. So make sure you look at Schoology for additional problems. So we are going to use, so it says state the congruency postulate or theorem that can be used to prove that triangles congruent. Use side, 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 angle, side, angle, angle, side, angle, HL, or none. Okay, so we can only mark things that we know are congruent. You can't assume anything. Okay, so the good news is these two angles are already congruent. These two angles are congruent. So we have two angles of these triangles. So we're going to use probably angle, like two angles. And hopefully, you know, we can mark this because the reflexive property, that's angle, side, angle, angle, side, angle. So it matches up. And therefore, I can prove those two triangles are congruent because of ASA. Okay. The next one, I have these two. So I have a side and I have an angle. I have a side and an angle. And the good news, once again, the reflexive property, I share a side. So it is going to be side, angle, side, side, angle, side. Okay. Next page. Number 30. Not much is marked. So I'm only telling you, I'm giving you one set of the angles match up, and we know a side match up, not enough information. Okay, I would need more. I can't assume. I can't say, hey, well, that looks like, they're the same. Number 30, not enough information. Okay, so then for this one, we can see an angle and side matches up so far. And even though they don't mark these angles, we're allowed to mark them because we know vertical angles. So since they are vertical angles, angle, side, angle. Okay. So for number 32, what I need you to realize is right now, this one would be, so I can mark the angles. These are vertical, but this triangle is side, angle, side, but then this is angle, side, side. No, no. So this is a none. Okay. And then this is the same thing. So if you skip down to number 34, it's the exact same problem. Okay. So I think I had a little typo there, but this is also none because they're not matching up. Okay. One triangle is showing SAS, the other one it's not. Like if this was marked, if this and this was marked, then I could say side, angle, side. Okay. So just be aware of that. Okay. Number 33. We know a side and an angle, and we include this. So this is just side, angle, side. Okay, side, angle, side, side, angle, side. Okay. And then number 35, the good news is we have a right triangle. And if we have a right triangle, the hypotenuse and a leg need to be just marked off. And in this case, we do. We have the side opposite to 90, the hypotenuse, they match up, and we have a leg match up. That's why we just say HL, hypotenuse, leg. And it only works if we have a right triangle. Okay. So then the next thing you have are just 4 proofs. So make sure you look at the reason. I will provide a sheet that has all the reasons that we can use. And the main thing is if your proven triangles are congruent, this is what we're looking for. Okay. With this first proof, you need to notice that you're told you have perpendicular. Soon as we see perpendicular, we are thinking 90-degree angles. Okay, so that fact that AD is perpendicular to BC, I can mark those 2 angles. Okay, they have to be 90. And then the other thing that I can mark right away is we're told that BD, so BD, must match up with CD. So I expect you to mark up your triangles based on the given. So first thing is perpendicular. And then what will follow because of perpendicular, I know we have right angles because we know what perpendicular means. It's a definition of perpendicular lines. Okay. Now notice I am not stating anything about a right triangle. Okay, so unfortunately, we're not going to use HL. Even though this is a right triangle, we're not going to have enough information to prove the triangle is congruent because of HL. So all I'm establishing is that these 2 angles, this angle and this angle, are congruent because all right angles are congruent, and that is the right angle congruence theorem. Okay, so all right angles are, of course, congruent to each other. They're all 90 degrees. Okay, so then my next statement is BD. So make sure you realize BD and CD, only reason we know that they are congruent to each other is because it was given. Okay, so this time I separated the givens. Okay, but then everybody should recognize AD is congruent to AD. That is the reflexive property of congruency. Okay, now I have enough information to say that my triangles are congruent, so that triangle DAB, it must be the same as CAD, and it's not HL though. Notice that my side opposite to 90 degree is not marked, so it's not the hypotenuse, but I do have side, angle, side. So I have side, angle, side. That matches everything up, and if this matches up, then all corresponding. So the whole idea of this proof is I wanted to show that BAD, this angle right here, we wanted to know why it must be the same as this angle. Well, once the triangles are matched up, all corresponding parts of congruent triangles must be congruent. That forces, if you can kind of visualize folding this triangle up, C matches up with B, this angle, both my right angles of course match up, and then these two angles would match up. Okay, all corresponding parts of congruent triangles must be congruent. Okay, then this next proof, notice I am telling you that A is the midpoint, but I only tell you it's a midpoint of MT. Okay, it's not necessarily the midpoint of SR. Okay, we don't know that. We're only told it's the midpoint of MT. And as soon as I know that, I can mark these two congruent to each other because a midpoint is going to divide a segment into two equal parts. Okay, so let me make sure you can see my A yet. So this is A, but that's the midpoint. So that was given. And as soon as you see something about midpoint, notice I'm allowed to mark MA is congruent to TA because that's what midpoint. The only reason we know that they are congruent is because we're applying the definition of midpoint. Okay? Then I'm hoping you realize and mark this up. We are told MAS, this angle, must be the same as TAR. And you have to recognize that these are vertical angles. Okay, so by now we should know vertical angles, and we're told we had a theorem that said all vertical angles are congruent. Okay, that's why we're able to say that they are congruent to each other. And then just be on the lookout for this. M is congruent to T. The only reason I'm allowed to say M and T are the same, so let's mark it with a double. Okay, M and T are the same because it was given. We were told, so let's go back so you can see this. We were told that those two angles are congruent, which makes it very nice. That was given. Okay, so again, when you're doing proofs, kind of refer to your diagram, refer to what part of the statement that we're referring to. So then, soon as we see this, I am hoping everyone realizes we have an angle, we have a side, and we have an angle. For this one, we have our angle, we have the included side and an angle. These must match up. Now, again, this angle would have to match up down here. So basically, you fold it over, then twist it, and then you'll see that S and R matches up. So we see that S and R match up. So the reason is angle, side, angle. And once we have that, these two triangles are the same, all the corresponding parts, SA, so SA and RA must match up because corresponding parts of congruent triangles. We already established that they're congruent triangles, ASA, and that's all you need. You get an extra point to be able to then show that SA, so we're saying SA, this must be the same, but we only know that because we already established that the triangles are congruent. Okay, one last proof. And then you need to make sure you look at all the other proofs, like in our notes, just so that you are getting enough practice on these proofs and the reasons. So again, there should be no surprises on your test. Okay, here I see parallel. Okay, so if you see parallel on your test, what you're going to be thinking of, hey, did I establish alternating interior angles? Okay, so let's mark our parallel lines. I am telling you, WX, so this side, and YZ, they never intersect. You extend them forever. They never intersect. That was given. Okay. Now, it's also given, and I'm going to mark it as well. We're also told that this side, WX and ZY, so we're given a side that are congruent. So this side matches up with this side. Okay, so now, why are we able to say XWO? So mark this angle. So there's your XWO is the same as YZO. I am hoping you realize we have parallel lines cut by a transversal. These are alternating interior angles, and there was a theorem that said they must be the same. Okay, so that's what you need to be on the lookout for on your test. Okay, so then I have this statement again, WX, the only reason we know WX and ZY are congruent is because we were told that they were congruent. Okay, we were also told that they were parallel, but it was nice to be told that we have a side. So far we have a side, we have an angle. Okay, so then our next thing that we're going to see is we're going to be able to establish another angle must match up. Okay, and the angle that must match up is XOW. So I'm going to mark this with two little slash marks. Must be the same as YOZ. And I'm hoping by now, seen this multiple times, they're vertical angles. Okay, and we know that all vertical angles must be congruent. Okay, so vertical angles theorem, and then please mark so that you realize what we have is angle, angle, side. You cannot say angle, side, angle. So this side is not in between the two angles that are marked. Okay, so the reason we can say that these two triangles are congruent, so again, if you're thinking about how these match up, you would fold this over, but then twist it. W has to be up here with Z. Okay, W and Z match up with this congruency statement. But the reason is angle, angle, side. Okay? Make sure you understand that. Okay? So please, again, look over this. You'll get this paper. Now, for this, the review, we didn't say anything about a segment bisector or an angle bisector. So if you don't see that as part of a given, you're not going to use it. Okay? But if you did see something about, hey, this is bisecting an angle, then we know that creates two congruent angles. Okay, then you would use the definition of an angle bisector if we see that, or we could bisect the segment. So if we take a segment and we cut it in half, bisected, then we can say the two sides are congruent because that's what a definition of a bisector is. So again, look at the given. I am hoping that you cared about this, that you checked all your answers, that you come into the test knowing this, and you should do well. Okay? Thank you for watching. Take care.